as I was saying, the classification. Now, pure substance, it can be classified into elements and compounds. Now, elements and compounds, in this, the element will have same atoms. Here, the difference is it will have different atoms. That's all. Okay. Now, here you can see, say atom, say it can be atoms or molecules. What is the meaning? Atoms will be a single entity which is indivisible. The name itself has come from atmos, which means indivisible. So, for example, copper or gold, silver, etc. These are atoms. But what is a molecule? It will have the same atoms, not more than one time. For example, you have O2, H2, then you have P4, which is for phosphorus. You have hydrogen, you have oxygen, you have fluorine, you have chlorine, you have bromine, and so on. So these are the examples of molecules. Now compounds, you have say ammonia, you have glucose, and so on. So here you see more than one atoms are present. You have water, more than one compound, atom is present, right? Now, you can take an example. You have one atom of hydrogen and one atom of hydrogen. If you combine them, you will get one molecule of hydrogen. This is how it's formed. So one atom will give you one molecule. So it's very clear what is a molecule here. Similarly, you have one atom of oxygen plus one atom of oxygen, you will get one molecule of oxygen. Right? You have understood one atom, one molecule. Now, how a compound is formed, you can see. You have already formed two molecules. Now, one molecule of hydrogen and one molecule of, actually, two molecules of, this is hydrogen, yes, plus one more molecule of hydrogen plus one more molecule of oxygen will give you what? Two molecules of, sorry, two compounds, two molecules of the compound named as water. HO. You have oxygen, you have hydrogen over here. This is what you get. So this is water. Here a peculiar thing is there. The peculiar thing is hydrogen is a gas which combusts with a pop sound. Okay, and that's why new fuels have been emerging. I mean new vehicles have been emerging which uses hydrogen as fuel. A whole science is there. I mean whole branch of engineering is there which follows that. So hydrogen is a very promising thing for the future. So hydrogen burns, oxygen supports burning. When you mix them, what do you get? You get water. And what do you use for water for? Water is used for extinguishing fire. It's very magical, that's how God plays. See, hydrogen burns, oxygen supports, and you mix them, you get water which extinguishes them. So these are the things. Now, similarly, there are certain other things like properties of matter. I will not be writing that. I'll just talk about that. Properties of matter. We said chemistry also deals with properties of matter. Now, properties of matter, it can be physical property or a chemical property. Now, physical properties which you can perceive or you can measure. For example, you have odor. Odor means smell. You can smell it. It's perceptible. You can see the color. You can feel the. You can measure the melting point. You can measure the boiling point, density. These things are physical properties. Similarly, you have chemical properties which are say combustibility or basicity, acidity. All these things, reactivity. These are chemical properties. Now, properties are also divided into two branches. That is, one is intrinsic property and the extrinsic property. Intrinsic properties is a property which is independent of mass. Extrinsic property is a property which is depending on mass. For example, you have a container, it has some gas in that, you are dividing that. So half mass has come here, half mass has come here. Okay, But similarly, volume has also come to half. So volume is depending on mass, so it is an extrinsic property. But temperature of this part will be equal to the temperature of this part, and it will be the temperature of the whole part. So temperature is intrinsic property. I hope it is clear. Density is intrinsic property, it is independent of mass, but the weight is extrinsic property. Okay, these are about properties. Now how to measure the properties? Any measurement you need a magnitude and a unit. You will have a magnitude and a unit. And unit, there are many systems, and actually there are two very prominent systems. One is metric system and the other is English system, and we follow metric system, which is very helpful because it follows decimal system. Okay, now since time is very less, I'll conclude with final topic of laws of chemical combination. Now we have learned about matter, we have learned about atoms, molecules. Now we must learn how they combine with each other. It's not like you put something, it will combine as in many different ways. No, it follows certain laws of chemical combination. For example, you prepare a curry. What will you do? You will take certain ingredients according to some recipe. You will not add 1 kilogram of sugar to a small bowl of curry or something else. So you follow certain laws, that is called recipe. Similarly, the chemical combination also follows certain laws, and I'll just tell one law and we'll wind up because the time is very less. I am very passionate about teaching and I have lots of things to teach you people, but the time is very less. So I'll just teach you one law and we'll wind up. The first law that you can see is law of conservation of mass. Now this was put forth by Antoine Lavoisier in the year 1789. Okay. Now he conducted a lot of experimental study on combustion reactions, and finally he found the reactants, the mass of the reactants and the mass of the products, and finally he put forth this theory. I'll explain with an example. Let's take an example. What does this theory state? This law states that mass can neither be created nor be destroyed. Now you can take an example. H2, your easy example. H2 plus O2 gives 2H2O. Now this is a chemical reaction. Now let's take the mass of atomic mass of these things. So here you have 2 into 2, which is 4, plus this is 16 into 2, that is 32. Here you have 2 into 2 plus 16, that is 18, that is 36. So here you can see that the mass is conserved. Here 32 plus 14, 32 plus 4 is 36. So here also you get 36, there also you get 36. So here we have, I've just shown you that the law of conservation of mass is fulfilled. Now similarly there are many other laws like laws of proportion, law of definite proportion, law of multiple proportion is there, then Gay-Lussac's law of volume, and Avogadro's law. Everything is there. In the coming lectures I will be teaching about that. Thank you. Don't forget to like this video, and please select me as a faculty based on my teaching. Thank you.